Alright, use the figure and paragraph proof that illustrates that the medians of a triangle are concurrent. Read the statements and decide how to fill in the blanks correctly. So I would honestly duplicate this tab, pull it up, and I'm looking for a proof that illustrates that the medians of a triangle are congruent. So I'm going to click Show All. And it says a paragraph proof, so I'm going to scan for a proof. So this is a paragraph proof, and this is talking about medians of triangles. However, it's not saying that they are concurrent. So I'm going to keep scanning. And that actually may have been it, just based on this example. Use the concurrency of medians of a triangle to solve a problem. Okay. Well, this might be our resource, and let's see if we can have some context clues first. So triangle ABC is constructed so that E is the midpoint segment of segment AC and F is the midpoint of segment, okay, so here's segment AC, here's E. Point F is saying it's the midpoint of segment, so it would be segment CB, because midpoint means that both segments on either end of that point are the same. So here's one endpoint, here's the other endpoint, so it'd be BC. So one's done. And then segment BE and segment AF are constructed to meet at point G. Then line N is constructed so that it is parallel to segment AB, and segment EF is the mid-segment of triangle ABC. By the blank, we know that angle EFG is congruent to angle BAG, and angle FEG is congruent to blank. Okay. So let's look at where angle EFG is. We have angle EF to G, so this is the angle. And then we have angle BAG, so angle from B to A to G. So it's this angle. First, I'm noticing that it is on a parallel line, N, and parallel to AB. It was stated right there in statement 3 that this line N was constructed to be parallel to segment AB. So we do have parallel lines. We also have this transversal right here of FA. Then all we are going to do is identify these angles. Are they on the same side of the transversal? So there's the left side of the transversal, there's the right side of the transversal. Angle EFG is on the left side, angle BGA is on this right side, so they're alternate angles. And are they inside the parallel lines or outside of the parallel lines? They are definitely inside the parallel lines, so they're alternate interior angles. So 2 is going to be the alternate interior angles theorem, because we know alternate interior angles are congruent when you have parallel lines. Now it's wanting to know angle FEG is congruent, so angle FEG, it's setting it up similarly. So angle FEG right there, here's our angle, is going to be congruent to, well, I'm going to go off of, since right here it says alternate interior, and this is in the same statement, this one has to be alternate interior as well. So alternate interior kind of creates a Z, if you noticed, with the angles of the Z. So there's one angle of the Z, here's the other angle of the Z. Alternate interior. So it'd be GBA or EBA. Let's see what they have. They have GBA. So GBA again was that. Yep, GBA represents this angle. So there is how we just read through this proof to answer the questions. So glad that we didn't have to use and decipher this for our help.